In this video we'll talk about solving logarithmic equations, and we'll talk about this one in its kind of a weird order. This one we'll use kind of before we talk about solving other exponential equations. So let's go ahead and just kind of run through an example here. Let's say we have log base 2 of x is equal to log base 2 of 3. And at this point, similar to solving exponential equations, I have single log with the same base is equal to a single log with the same base of a different number. So the only way that this can be true is if these two things are equal. So this would tell me x is equal to 3. And very similar to solving exponential equations, this is going to be the motivating thought behind solving some logarithmic equations. It won't work for all of them, but if I have equations involving logarithms on both sides of the equation, this is the governing thought. So let's take a look at a slightly more complicated example. Let's say we have log base 2 of x plus log base 2 of 3, and that's going to be equal to log base 2 of 4x minus the log base 2 of 7. Now this is a little more difficult in that I don't have a single logarithm, but I think we can make it so using our properties of logarithms. If I'm looking at this, I have addition on the outside, so that means I can rewrite the left side of my equation as log base 2 of 3x. Addition on the outside means multiplication on the inside. And likewise, with subtraction over here, I can say, okay, this has to be equal to log base 2 of 4x divided by 7. I just have to be careful with the order there, since the log base 2 of 7 came second. That's why it's in the denominator. Now at this point, I have log base 2 of some stuff equals log base 2 of some other stuff. So therefore, the stuff must be equal to each other. So I can say 3x has to equal 4x divided by 7, which we can multiply both sides by 7 to make it a little easier on ourselves. So we're looking at 21x is equal to 4x. And then we can say, well, subtract 4x, for example, and we can say 17x has to equal 0, which means that x is equal to 0, and that is our solution. Now, it's worth noting we should plug these in to make sure they're feasible. We can plug 0 in sometimes, but right here and right here I have a problem. I can't actually plug 0 into my logarithm because there's a vertical asymptote there. I don't know what that means. So actually in this case, there would be no solution. The only one that would work would be one that I actually can't plug into a logarithm. So that's always something that's possible. Just be very careful. And just keep in your mind, is it possible for me to plug this back in to my original equation? And that is kind of the governing thought. We'll talk in another video about how to solve logarithmic and exponential equations. They kind of go hand in hand, so we'll do one video where it kind of connects the two.